Hello everyone. Today's video is about thrust and center of pressure. It's just picked up one question from the past papers. Bulkhead is 10 meters in height. The horizontal ordinates at equal intervals starting from tank top are as follows: 12, 10.6, 9, 7.2, 5 and 2. Calculate the thrust on the bulkhead and the height above base. It can be considered to be acting if the tank is filled to head of 2 meters. So one thing to note here is that the ordinates given are horizontal ordinates, and the tank is filled to a head of 2 meters. Head of 2 meters will mean that the water level is extending 2 meters above the tank top. That is what the meaning of head of 2 meters means. Whereas for some reason the density of the liquid is missing, so we will assume salt water, and I will calculate with assuming salt water. Maybe it was announced later in the examination hall. That doesn't matter. We have to see the working. So we need to know the thrust on the bulkhead and height above base. From the above base is from the bottom, where this thrust is considered to be acting, and that means center of pressure. So a brief discussion on center of pressure and thrust. The center of pressure will not be the geometric center of the bulkhead. Why? Because we know that the pressure, liquid pressure of fluid or fluid pressure is increasing with the depth. It's minimum at the top of the on the top of the bulkhead, and it will be maximum at the bottom. So as we go down deeper and deeper, depth is increasing. The pressure is also linearly increasing. So definitely it cannot be the center of pressure, cannot be the geometric center or centroid of the bulkhead. It has to be below the geometric center towards the bottom of the bulkhead, because it's increasing as we are going downward. The depth is increasing. So here in this diagram, G is the geometric center and Z is the center of pressure. It's below the geometric center, centroid. These are the ordinates, horizontal ordinates: 12, 10.6, 9, 7.2, 5 and 2. And this is a sounding pipe or the air pipe, and the water is liquid is extending 2 meters, because it says tank is filled to head of 2 meters, not to the sounding of 2 meters. Sound is saying to the head of 2 meters. So above the tank top 2 meters, and this WS is a water surface in the pipe, in the sounding pipe. This is a tank top, and we will have to do this question with Simpson's rules, but there are 6 ordinates given: 1, 2, 3, 4, 5, 6 ordinates. That means we have to split our bulkhead in 2 parts. So that one part can be calculated using Simpson's rule number 1, and the second part using Simpson's rule number 2. So what will be the common interval? The height of the bulkhead is 10 meters and there are 6 ordinates. That means number of equal intervals will be 5. 6 minus 1. So you can see that this is 1, 2, 3, 4, 5. So h will be 10 upon 5. That will be 2 meters. I have taken top 3 ordinates, 12, 10.6 and 9, as calling them as area A1, and we'll use Simpson's rule number 1 for calculating this, the top portion. A1. And from 9 downwards, 9, 7.25 and 2, these four ordinates comprising area A2, the bottom portion. And that will be done by Simpson's rule number 2. Now remember that when we are calculating center of pressure, the formula of center of pressure is equal to moment of inertia I about water surface upon area of the immersed surface into d is the distance of the geometric center of the immersed surface again from the water surface. So all distances, our moments are from water surface in the formula. So in our calculations, if we take our levers from the water surface, we will get the answer straight away, and that will be faster, easier and faster. Another method is that you take the levers from tank top, like normally you do in Simpson's rule. If you take the levers from tank top, then you will have to apply theorem of parallel axis 2 times. You will get the moment of inertia about tank top. Then you will have to get the moment of inertia about centroid, axis passing through the centroid by applying parallel axis theorem. Then you will have to get moment of inertia about water surface, again applying parallel axis theorem. So you will get the same answer, but it will be a little longer and a bit complicated. So it's the best thing in this situation of horizontal ordinates is given that take the moments from the water surface. So H is 10 upon 5, which is 2 meters. So let's concentrate on top area A1, which comprises of 3 ordinates, 12, 10.6 and 9. So Simpson's multiplier 141, we get the area function, multiply the ordinates with Simpson's multiplier 12, 42.4 and 9. Then I'm taking lever from the water surface. So the first ordinate, which is a tank top, value is 12 meters. Its distance, the lever will be 2 meters because water surface is 2 meters from the top ordinate. From 12 ordinate number 12.0, the water surface is 2 meters. So the lever for the first ordinate from tank, which is a tank top, will be 2 meters. Okay, and then our common interval h is also 2 meters. So the next ordinate 10.6, the lever will be 4, and the third ordinate for 9.0 lever will be 6 from water surface. So multiply the area function with the levers from water surface and we will get the first moment of area about water surface because we are taking levers from water surface. So 12 into 2, 24, then 42.4 multiplied by 4, 169.6, 9 into 6, 54. So we got the first moment of area function about water surface, WS. Now we need the second moment of area, which is called moment of inertia. Second moment of area means again multiply by the same lever. The lever remains the same, 2, 4 and 6, and multiply the first moment of area with the lever again. That's why it's called second moment of area. And we get second moment of area again about water surface because that is what is needed in the formula. So 24 multiplied by 2, 169.6 into 4, 54 into 6. We get the second moment of area. Now all the sums of the products. First will be the area function. Add up, we get the SOP, sum of the product. Then we have first moment of area sum of the product 247.6, and then the second moment of area, sum of the product is 1050.4. Okay, what will be the area A1 then? Simpson rule number 1, h by 3 into sum of the products. H is 2 meters, so 2 by 3 into sum of the product is 63.4, and we get the top area A1, 42.267 meters square. First moment of area about water surface, same formula, h by 3, sum of the product, h is 2 meters, to 2 by 3 multiplied by 247.6, which is the sum of the product for first moment of area. And we get the first moment of area as 165.067 meter cube. Second moment of area about water surface, h by 3 into SOP. So 2 by 3 multiplied by sum of the product is 1050.4, and we get 700.267 meters to the power 4. This is second moment of area. So we got the area, first moment and second moment, all three for the top portion, top part of the bulkhead. Okay, now we move on to the bottom part of the bulkhead, which is area A2. We call 4 ordinates, starting from ordinate 9, 7.2, 5.0 and 2. Simpson's multiplier 1331. Area function we multiply with the Simpson's multiplier with 9, 7.2 into 3, 21.6, 5 into 3, 15, 2 into 1, 2. Okay. Now the levers are again from the water surface, from the top water surface. So for this ordinate, which value is 9, the lever is 6 meter from the top water surface. Then after that common interval h, you add 8, then 2, 10 and 2, 12. So these are the 4 levers. Multiply the area function with lever and we get first moment of area for the bottom portion. Again about water surface. So we multiply 9 into 654, then 172.8, 150 and 24. So area function is multiplied by the lever to get the moment of area. Then same levers again, 6, 8, 10, 12, same levers. We multiply the first moment by the lever again and it becomes second moment of area. About WS, which is the water surface. 54 into 6, 324, and 172.8 into 8, 138.2.4, 150 by 10, 150 into 10 is 1500, 24 into 12, 288, and now add up the second moment of area, sum of the product, 3494.4, first moment of area, sum of the product, 400.8, and area function, sum of the product, 47.6. So same way now we calculate with Simpson rule number 2 is 3 by 8h. H is 2 meters. 3 by 8 is the coefficient for Simpson rule number 2. So 3 by 8 into 2 and area sum of the product is 47.6. So bottom area I get 35.7 square meter. And first moment of area about water surface, same 3h by 8. So 3 by 8 into 2 into sum of the product, which is 400.8 for first moment of area. And we get first moment of area 300.6 meter cube. Then the second moment of area about water surface, which is also called moment of inertia, IWS. This is IWS because second moment of area is moment of inertia. 3h by 8, h is 2 meters, 3 by 8 into 2 into sum of the product. for second moment of area 3494.4, and we get 2620.8. So what we got now? We got for the top area A1, we got the area, first moment of area and second moment of area. Then for the bottom portion, area A2, we got the area, first moment of area and the second moment of area. So we will add all these up and we'll get total area, then total first moment of area about water surface and total second moment of area about water surface. So first we add up the area A1 plus A2, 42.267 plus 35.7, and total area of the bulkhead is 77.967, which is immersed in the water. Then first moment of area 165.067 plus 300.6, top portion plus bottom portion, and total is 465.667. Then total of the second moment of area about water surface. So from area A1 we got 700.267, and from area A2 we got 2620.8. We add them up and we get 3321.067 meter raised to the power 4. So these are the now total area and total first moment of the area and total second moment of the area. Center of pressure from WS, from the top water surface, called Z, and the formula is moment of inertia, which is second moment of area about water surface upon area, immersed area of the bulkhead multiplied by the distance of the centroid of the immersed area, again from water surface. So IWS we have found with total second moment of area is 3321.06, which is the total second moment of area. Now total immersed area into distance of the centroid from water surface is nothing but moment of the area, first moment of the area. So A into D will be first moment of the area, which is 465.667 here. 465.667 is the total first moment of the area, because total area A multiplied by distance of its centroid from water surface, depth of the centroid from water surface, that is nothing but moment of the area, first moment of the area, which is 465.667. So I get 7.132 meter is the distance of the depth of the center of pressure from the water surface, and total height of the water surface from the base is 12 meter. 10 meter is the bulkhead and 2 meter is the head. So total height of the water surface from the base is 12. So 12 minus 7.132 gives me 4.868 meter is the center of pressure from the base. Position of the height of the center of pressure from the base of the bulkhead, 4.868. What is thrust? See, pressure is force per unit area, and thrust is pressure multiplied by the total area. So how much force, total force is acting at the center of pressure. So, and we know that pressure is given by density of the liquid, rho here, density of the liquid. Then we have D, which is the distance of the centroid from the water surface, and A is the area of the immersed surface of the bulkhead. So once again, total area of immersed area multiplied by the depth of the centroid from water surface, A into D is moment of the area, which is 465.667 multiplied by 1.025, assuming salt water density. So if there is any other density was announced, we can just change the density here and you will get the thrust. total thrust 477.309, assuming salt water. Okay, that's it. Let's see the from how you calculate. So main thing was that in case of horizontal ordinates, you can safely take the moments from the water surface itself. That will avoid complicated long calculations of you applying the theorem of parallel axis in this case, at least when the horizontal ordinates are given. I have double checked. I have calculated the same question by doing the other method, like first take the moments from the tank top, then apply the parallel axis theorem and get the um, moment of inertia passing from the axis passing through the centroid IgG. Then apply again parallel axis of theorem and get moment of inertia about water surface 2 times. It's longer, but exactly same answer to the 3 decimal place it comes. Exactly the same answer. So the clever thing to do is take the moments from the water surface. You will save time and the calculations will be also accurate. Answer will be absolutely correct. Otherwise, you will have to find D. D is the distance, the depth of the centroid of the immersed bulkhead from water surface. That will be longer method, but you know that area, immersed area A into its distance of the centroid from water surface is nothing but first moment. First moment if you have taken the moments about water surface. So first moment of area about water surface is nothing but A into D, which is here for 65.67 total. So I don't have to calculate D separately. I don't have to calculate A separately because I'm getting the moment, first moment of area. Use that. Okay, thank you very much. And if you have any questions, you can put in the comment section.